So 9.6, using the quadratic formula to solve quadratic equations. So recall the following. A quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c equal to 0, where a can't be 0. So again, you must have an x squared term, and again, x terms and constant terms are optional whether they're there or not. So b and c, these coefficients can be 0. In the last few sections, we've been focusing on solving quadratic equations in one variable. So again, keeping in mind this verb to solve means to find, in this case, values of x, since we only have one variable present now. So find values of x that make the equation true. And so far we've done that through factoring and using the zero factor property. The quadratic equations that will get to best fit certain data will not factor. Most quadratic equations don't factor nicely with integer coefficients. So one way to solve any quadratic equation in one variable is with something called the quadratic formula. So the solutions of a quadratic equation, when we write it in this form, so again we have to have all of our terms on this side, and again set equal to 0, just like our first step when we were trying to use the zero factor property. And again, a can't be 0. We have to have the x squared term, and then again, x terms and constant terms are optional. But to get the values of x that make this equation true, we're going to take the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. And in here we've got lots of places where we've got variables that we're going to substitute, and again we're going to be placing some parentheses around those before we do so. So example 1 says to use the given function to answer the following. So we're given y equals 5x squared minus 11x plus 2. And it says to use your calculator to graph using Zoom 6 and to label the y-intercept on our graph. Alright, so on our calculator, if we push y equals to get to our screen, and if you've got other equations here, we can clear those off. And then in that window, we are going to type 5x squared minus 11x plus 2. And then Zoom 6 will take us back to the standard window that runs from -10 to 10 on both axes. And we get a graph that looks like this. Okay, and we can see it crosses our y-axis right here, and that y-intercept is the output we get when our input is 0. So from the table over here, we can see for an input of 0, we would get an output of 2. And we can see that from the equation as well. Alright, so for our y-intercept, that's an ordered pair 0. What is our output when the input is 0? So again, if we input 0, these two terms become 0 plus 2 gives us 2. And so on our screen here, we had, so where's our graph? We had something that came down kind of skinny and crossed in a couple different places here on the axis. Like this one looks like it crosses maybe around near 2, somewhere near 0 or slightly positive there. So we have kind of this thing that comes down like this, and we have a point here at 0, 2. So looking at the graph above, how many x-intercepts does the graph have? So how many times does it cross the x-axis? And we can see that it comes down and it crosses here, and then it makes a bend and it crosses here again. So we've got 2 places where it crosses the x-axis. Well, how would we go about finding where those occur? So we're going to find those x-intercepts using the method of factoring first. So x-intercepts means that we are after the points that are of the form x comma 0. So we're going to plug in y equals 0 and solve for x. So if we do that in this equation, we get this equation to solve. And they told us to solve by factoring, so it should factor nicely for us with some integer coefficients. So the only way we can get a 5 is 5 times 1 with integers. And in here we've got plus 2. And if we play around a little bit with those, we'll see that what works is to put a -1 here and a -2 here. And so that's going to give us our -10x minus another x gives us -11x. Negative times a negative does give us our +2. So now we've got the product of two things equal to 0. Okay, so one of these has to be equal to 0, at least one of these. And so if we solve for x, we're going to get 5x equals 1 and x equals 1/5. And here we'll get x equals 2. Okay, so again, we were after the x-intercept, so we know for an input of 1/5, that was one of our x-coordinates, that will give us an output of 0. And we know an input of 2 will also give us an output of 0. And if we look at our graph that we made on the calculator, those answers make sense. Okay, so this did look like it crossed around to 0, and this one looked like it was pretty close to 0, so at 1/5 and 0 for our two x-intercepts. Okay. This one happened to factor nicely, okay? Especially when we start fitting data, we're going to find that they do not. So we're going to also look at finding the x-intercepts on this one using the quadratic formula. So again, to get the x-intercepts, we are after points of this form, and so we need to solve the same equation again for x. Well, without factoring, we're going to use the quadratic formula, and the quadratic formula says that we have to have a 0 here, which we do, and then our coefficient on x squared is our a, coefficient on x is b, and our constant is c. Okay, so for this one we've got a equals 5, b equals -11, and c equals 2. So now if we plug in our formula, we've got x equals the opposite of b plus and minus the square root. Again, before we substitute for variable, we're going to put parentheses just like we did here, so b squared minus 4ac all over 2a. So the opposite of -11 is +11, so minus square root. -11 times -11 is 121. And 4 times 5 is 20 times 2 is 40, so we get minus 40. And 2 times 5 we get 10. Alright, so under the radical, 121 minus 40, we get 81. And the square root of 81 is 9. Okay. So now, this plus and minus gives us our two answers. So we're going to get one of these answers is going to be 11 subtract 9 over 10. So that gives us 2/10, which reduces to 1/5. And our other answer, we're going to get 11 plus 9 over 10, which gives us 20 over 10, which gives us 2. Okay. It's the same equation, so no matter which method we use, as long as we did legal math, we should end up with the same solutions. So again, this tells us that our x-intercept is at 1/5, 0, and 2, 0.